Hi there, your LangChain app works perfectly fine in dev. It works fine with 100 users, then something changes. You get numerous amount of calls per day and everything starts falling apart. Cost explodes, latency spikes, random crashes, you are getting paged at 2 a.m. Today I am going to show you what exactly breaks and how to fix it. 5 failures, 5 fixes, let's go. Okay, so the problem number 1 is no caching. This is the most expensive mistake you can make. Most of the chatbots in production got around 40 to 60% of queries duplicates or near duplicates. So now let's imagine that you made a chatbot and you get queries in this manner. So as you can see that most of our queries are semantically similar. So do you think that it would be feasible to pass all of these towards the LLM and get the response? As don't you think that we are getting the unnecessary cost? As you can see here that we wasted 5 calls because 5 queries were duplicate, and if at these queries would be at scale, then there would be huge cost issue. And the problem number 2 is LangChain default setup is synchronous. So if user A is making request, user B will eventually wait, not in a queue, just wait. At lower traffic it's fine, but at scale your P95 latency becomes your average latency times your queue depth, which is a huge issue. And the problem number 3 is most of the apps in production or having queries at scale get 429 error, which is a rate limit error. So the question is, do you want your app to gracefully retry or crash? And the problem number 4 is like the single model dependency, like I am doing here. I am using only single model GPT-4o, and imagine it goes down and it goes down. So what do you want? Whether you want your service to go down with it or shift towards the other model. And the problem number 5 is cost guardrail. Imagine there is some person who is submitting 50,000 token document in a loop. There is no upper cap or limit on your API key, so you don't know whether the user is exploiting or not, and you get to know at the billing time. Okay, so as we talked about the problems, now let's talk about the fixes. Okay, so for the first one, the non-caching problem, we can add the cache. So there are two options right now for us. First of all, the in-memory cache, and the second one is we can opt towards the redis lang cache. So it's upon you, which one would you prefer. For the demo I am going towards the in-memory cache, but you can use the lang cache, which is the redis cache, and it is more faster than the in-memory cache and provides more uh, flexibility there. And the problem number 2 was synchronous call. So for that we can go with the asynchronous.gather. What it does, it run all of the queries in parallel. So let's assume that for the 10 queries that we had, if we run it here, so it would run all of the queries in parallel, and the max time would be the time of the slowest query in all of the 10 queries. And the third issue was the single fallback model. So for that we can add the fallback models via this. We can add dot with fallback model and tell the fallback models, and the fallback models can be uh, greater than 1, 2, 3, or as many as you want. And the problem number 4 was the rate limit error. So for that we can add the exponential backoff in this, where I am telling like stop after 4 retries, and the export, and here I am telling like first of all you will wait for 2 seconds, then 4, then 6, then 8, and so on. The max limit is 30, and it would do like only 4 times, and if it still fails, then it would then it would raise an issue that you will solve at the application level via this. And the fifth problem was cost guardrail. So for that, first of all we will add the per request token limit, and then per request daily cost cap, and a kill switch that will gracefully return the cached fallback response that wouldn't be visible to the user for the error. So these are the things that you can use towards the production, and via this, as you can see, that you can reduce your cost like this, you can add zero downtime, etc. Okay, so now let's compare the knife version with the production version. So on the left side we have the production variant, and on the right side we have the knife variant. As you can see, we use the same queries, and on the left side, as you can see, in the production variant we have around 50% cache hit rate, so we have saved around 50% of the cost. And also on the timing side or latency side, we have got way less latency than the serial, or you can say knife version. In at this level the difference isn't that much, but at scale you would notice the difference would be so much. And for the uh, fallback chain, I have used the GPT-4o mini here, and you can go with either Gemini or Claude, whatever you need. So this is it for the demo. Hope you like it. Do let me know if there is anything else. Have a great day.